Hi, my name is Tim Mao and I manage the technical support team here at X-Rite. Today we're going to be talking about IQC software and specifically about how we manage tolerances and use those tolerances to ensure that we're shipping good color to our customers. So let's dive into the software. You'll see that I have a job opened with my green color standard with a large variety of trials underneath. And those trials are identified in green if they pass, red if they fail, and if we scroll down, we even have one that's yellow and says margin. But how does the software know what to make for those determinations? We can find that out by launching into the settings dialog of our job, and when we do that, it automatically opens up the QC tab here at the top, where it tells us that stored in this job is the pass-fail using Delta E2000, and I've got a drop down to select other methods for tolerancing that. I'm going to stick with DE2000. Further down where it says system default tolerances, I can put in my pass-fail number. In this case, I'm using 1.0. And of course what that means is that any colors measured, any trials with a Delta E2000 less than 1.0 will pass. More than 1.0 are going to fail. You'll note that right underneath that we have something called a margin percent. And in the margin percent, we've got it set to 0.10 or 10%. What this means with a tolerance of 1.0 is that anything between 0.9 and 1, the top 10% of my tolerance, anything in there that falls in there is going to be labeled as margin, meaning I'm approaching failure, so it might be time for me to take some action. This is especially helpful if you're in the process of measuring repeatedly through a run, right? A batch of something. You're making 10,000 of them and you take a measurement once every 1,000 samples. If you start to see those trials starting to drift further and further from the standard, and you start moving from a green pass to a yellow margin, it can be an indicator for you to take some action. So the last piece of the tolerance that we want to talk about today is actually on a different tab. It's right next door on the tab called General, and that is which illuminant observer is being used. And the tolerance will use the first of your illuminant observers to do its pass-fail determination. So again, I'm using a D65 10-degree observer D65 10-degree illuminant observer with my DE2000 tolerance. So again, we can see the indications by the color of the dots, by the words over here. We have other ways we're displaying those measurements, visual representation, reflectance curves. Those two are useful, but not necessarily when we're evaluating a tolerance. But when we come over here to the scatter plot, it can be very useful. And so I can see the green dots and the red dots. I can see the green area of my tolerance. I can see the yellow area of my tolerance. And of course, anything outside of that is red. Now, one of the first things that jumps to me when I look at this is, why do I have a red dot that appears to be in the middle of the green tolerance? One of the nice things I can do is I can simply point at that and click on it, and it'll highlight that sample for me here and here. And I can see, while in the A and B directions, right, yellow, red, green, blue dimensions, that sample is inside the tolerance, the reality is it's too dark. And because I'm only looking at 2 dimensions here, I don't notice that 3-dimensionality. And that's why it appears to be a red dot that's passing, or should be passing visually. So another way to look at that is we can right-click here and maximize this to make it even larger. And then to understand the 3-dimensionality of it, we actually can switch to a 3D view. The 3D view, in this case I have it set as a wireframe, and with my mouse I can click and rotate, and you can see samples that are passing, failing, margin, and so forth, 3-dimensionally. That can help you understand why the samples fall where they fall. All right, I'm going to go ahead and turn off the 3D and restore this back to its size. Now, sometimes we make a determination that I've got samples like these, and I can double click here, by the way, and it'll highlight them out in the plot as well. right? So I have a 1.18 and a 1.19. Maybe my customer is visually accepting that, and even I visually accept it. It might indicate that I need to adjust my tolerance. Well, that is, of course, as simple as going back to where we started, and I'm going to change my 1.0 to 1.20 and apply, and hit OK. And now you'll notice that those samples that were failing, they're now in the margin because they're very close to that 1.20. But my sample that was at 0.96 and in the margin previously is now actually in the pass area because I've adjusted the tolerance to better agree with my customer. And that's ultimately the goal. Your tolerance should be designed so that it helps you determine what your customer is going to do. If it's passing, your customer should not be rejecting the product. And if you have a properly created tolerance, you can achieve that. Thank you for joining us today.